We will now look at graphical interpretation and the length of lines, and we will do so by just working through a few practical examples. So to start off, we've got this function, these two functions. We've got a straight line and we've got this parabola. And the first question says determine the length of OC. Now OC lies over here, and to find this length we need this x-intercept of the parabola. Now to find that, we're going to start off by solving for the x-intercept. So we have fx equals to negative 2x squared plus 4. So we're going to say where fx is equal to 0, therefore where negative 2x squared plus 4x plus 6 equals to 0. And then to solve for that, I'm just going to divide everything with negative 2. So I've got x squared minus 2x minus 3 equals to 0. Now I have to factorize. Now in factorizing, I say x minus 3 and x plus 1 equals to 0. So where x is equal to 3 or where x is equal to minus 1. Now on the graph, I can see that this is 3 and this is then minus 1. So therefore, my OC is 3 units, from 0 to 3 units. Then for B, we need to find BC. So BC being from negative 1 to 3, that's going to be, so BC is equal to 3 minus, if I take this value, the big value minus the small value, 3 minus negative 1 is equal to 3 plus 1, which is equal to 4. So I can do that like this, or I can just read it off the graph or calculate it from the graph. If this is 1 unit, that's 3 units, added together is 4 units. Now for C, we need to find OA. Now to find OA, we need the y-intercept of our parabola, and we can actually just see it over here. This is going to be at 6 because our C value is our y-intercept, and therefore for OA we have OA as equal to 6 units. And then for D, we want to find AE. Now once again, E is the y-intercept for the straight line, and we can see that lies at minus 2. Now to find this distance, we see that this is 6 units and this one is 2 units. So therefore AE is equal to 6 plus 2, which is equal to 8. All right, so now to go on to E, it's on a new page, GH in terms of x. Now GH is this length of line between the two functions. So to get this length, especially in terms of x, I need to take the top graph minus the bottom graph. So to do that, I've got GH is equal to the top graph. My top graph is the parabola, so that's fx minus the hx. Alright, so now we can just substitute in these values. So fx being this whole function here, we've got minus 2x squared plus 4x plus 6 minus, and important to put this whole of hx in brackets, we've got 4x minus 2. And then just to simplify, we have minus 2x squared plus 4x plus 6. Multiply in the minus is minus 4x plus 2, and then add the like term. So minus 2x squared, this 4x minus 4x becomes 0, and then 6 plus 2 is 8. So that gives us negative 2x squared plus 8. That's GH in terms of x. And now we want to find IJ if OK is 1 unit. Now this IJ is the same as this one in terms of x, because this is also top graph minus the bottom graph. And what this does, so we can also have IJ as equal to minus 2x squared plus 8, whereas GH is just the length where x is, say, 1, and IJ is the length where x is at minus 1, or let's say this was 2. So therefore IJ will then be equal to, now if I substitute in negative 1 for my x value, minus 2 and then minus 1, this gives me the distance where the difference or the distance between the two lines at x is equal to -1. So we have -2, and then this squared is a +1 plus 8. So this gives me -2 plus 8, which is equal to 6 units. Okay, the function of fx and gx are sketched below. Determine the lengths of OB. So we're starting with A. Lengths of OB. OB is this length, and this B value actually is the intercept of both of these graphs. So we can actually see that both of them have a C value of -16, which makes sense because both of them intersect the y-axis at -16, and therefore my length of OB, and remember it's a length, it's always positive even though it intersects here at 16, this distance here is 16, so OB is therefore 16 units. Then for B, we need to find AD. AD lies over here, so this will be, in finding that, we need to find the x-intercepts for G. So to take G of x, where G of x is equal to 0, so we set x squared minus 6x minus 16 equal to 0. In factorizing that, we'll have, so my factors of 16 is 1 and 16, 2 and 8, and 2 and 8 will work, because if I want to get -6, I'll say +2 minus 8. So factorizing this is x plus 2 and x minus 8 equal to 0. So therefore x is equal to -2, or x is equal to 8. So this is then my -2 if I read that of the graph, and that's my 8. Now my length of AD is then this 2 units plus these 8 units. So it's 2 plus 8, which is 10 units. And then for C, PQ in terms of x. Alright, so PQ in terms of x, we have the top graph minus the bottom graph. Now, I think I'm just going to do that on the next page, just on a clean page. So C, we want PQ in terms of x. So PQ is the top graph. Now here we have this one, which is F, which lies on top where PQ's distance is. So that's going to be Fx minus Gx, G of x. So to replace those functions or substitute them in, here we have -x squared plus 8x minus 16. Subtract the bottom graph, that's x squared minus 6x minus 16. Right, and then simplify. So minus x squared plus 8x minus 16 minus x squared plus 6x and then plus 16, and then we have a minus, and a minus is minus 2x squared. 8 plus 6, that gives us plus 14x, minus 16 plus 16, that's equal to 0. So this is then PQ in terms of x. So wherever PQ moves, it can move here. We can just substitute in the x value wherever x is, and that will give us the distance. So if we substitute in 2, we'll get this distance. If we substitute in 1, we'll get this distance. All right, and then for D, we need to find PQ if P has a x coordinate of 2. So if P's x coordinate is 2, and then something for y, so if this is at 2, so that means if we substitute 2 in for x, so PQ is equal to -2, replace x with 2, and then square root plus 14, and then again x with 2. So this is -2 times 4 plus 28, and this is minus 8 plus 28. So our units are 20 units. Okay, so now the function of fx. So once again, these are the other functions that we worked with earlier. And then the question states, for which values of x will GH be maximum, and what is the length of GH when it is maximum? So that means we have this GH, and we worked out what GH was in terms of x. we can just do that again quickly. So we have GH is equal to the top graph minus the bottom graph. So that's fx minus h of x. And then we substitute that in. So we have minus 2x squared plus 4x plus 6 minus the top graph 4x minus 2. So this is then negative 2x squared plus 4x plus 6 minus 4x plus 2. Simplifying that, we have minus 2x squared. So minus and plus 4x, that cancels. That's then plus 8. All right, so now we've got this GH in terms of x. So what we want is, we want to know where is this line going to be maximum? Where is this line going to be the longest when it lies between these two functions? And how we do that is we complete the square. So as we normally just complete the square for, when we complete the square for quadratic equations, now we're going to say, okay, GH is equal to, so first of all, I need to take out the negative 2. Then I'm left with x squared plus 8, or plus, actually minus 4 when I take out negative 2. All right, and then I say minus 2. My first two terms now, this one will be plus 0x over here. So if I write on it as x squared plus 0x minus 4, and then start by completing the square, we'll have x squared plus 0x, and then plus 0 over 2 squared minus 0 over 2 squared minus 4. So this will then be minus 2, and then x plus 0, because this, we take this x, this sign, and then whatever's inside this bracket. This one is just a bit unique because this is going to be 0, and then this term will also be 0. So then minus 4, this simplifies to minus 4, and if we multiply this back in, that means we've got negative 2, and then, okay, this goes in, x plus 0 squared plus 8. So this means then that this value is your p-value and your q-value. So your p-value is where the function is maximum. So it's going to be at x equals to 0, and then the maximum value for GH is going to be this 8. So this is going to be my maximum value. Okay, now for these two functions, find the distance PQ when it is maximum. So PQ when it is maximum, once again, we just want to find PQ in terms of x. So that means to find PQ in terms of x, we need to take the top graph minus the bottom graph. So that's going to be fx minus h, or gx. So to substitute in that, we've got negative x squared plus 8x minus 16, subtracted the x squared minus 6x minus 16. Then we have all of this again. So this is minus x squared plus 6x plus 16, and simplifying this is minus 2x squared. Then this becomes plus, these 16s cancel out, this becomes plus 14x. All right, so now we've got PQ now in terms of x. So now to complete the square, I'm going to say, take the minus 2 out first. So that's x squared minus 7x. And then in the next step, what I do is I just write down my first two terms, minus 7x, and then I add the 7 over 2 squared, and I subtract 7 over 2 squared. And there's no other term here, so close that bracket off. And then we group these three terms together. We have this x, this sign, and that's 7 over 2, and that's squared, and then minus 49 over 4 if we simplify the square. So this then just multiplies in, so that's minus 2, and then x minus 7 over 2 squared. Just notice that it can't multiply into a square bracket, so it just stays there. And then minus and a minus is a plus, and then if I multiply with a 2, this 2 and this 4 will cancel, so we'll just have 49 over 2 left. So this is where my line's going to be maximum. So at x equals to 7 over 2, my value, my maximum PQ is equal to 49 over 2. So this is where it's maximum, and that's what the length is when it is maximum.